Good morning, everyone, and glad to meet you here in the day we all celebrating our love and appreciation for Geographic Information System (GIS). My name is Hisham Gamal Gafar. I am leading the solutions for the EEC sector in Quality Standards for Information Technology. Our QSIT is located in Egypt. It is established in 1994, and we are golden partner for both Esri and Autodesk. Today, we're going to talk about BIM-GIS solutions for infrastructure utilities. Our agenda for this lecture is infrastructure utilities project lifecycle, the journey from day one until we reach the final day, BIM and GIS, what and why, and then what are the obstacles and challenges that face our industry, and one integrated solution or one integrated platform solution for BIM and GIS utilities. Project life cycle is always starting from the planning phase, where we should have a view for the outline of the project, the layout of the project. We have to get some information about the context of the new project. So we need these maps, maybe some GIS data like shapefiles, maybe CAD drawings, or some drawings or models, or maybe even paper work for the existing networks. So in the planning phase, we can see that GIS can provide a value for the planning engineer, which by default will lead to a better design. So now we move to the design phase. In the design phase, we build the detailed model and shop drawings for the construction or the execution engineers, so it will be ready for the implementation in the next phase, which is the building or the construction, the execution phase. In this phase, we need to have an easy way to follow up, to monitor the project, to have some progress reports using insights and indicators to make sure that the construction work is following the design drawings or models. Then we move to the longest period in the project life cycle, which is the operation, or we can call it the facility management. We need in this phase some way to do the facility management in an easy way, like inspections workflows, maintenance workflows, or even incident management. I think all of us have heard about the BIM, GIS, and also the integration between both of them. GIS, as I believe all of us know, that it is the technology that helps us to answer the question of where. it provides our solution or our project with the spatial intelligence to define the best site location for whatever I need to do. So the GIS can help me in the planning phase. Also, it can help me to in the operation phase to have an accurate geographic data for whatever asset I operate. And in the BIM-GIS solution we are suggesting today, or we are discussing today, we are trying to increase the level of details for our model. We're not talking today about BIM itself or about GIS itself. We are talking about a combination between both of them, BIM and GIS, to provide, maybe we can call a GeoBIM model, we can call it a CIM model or city information model, whatever you call it. We now have a need to create an aggregate model that contains the outdoor data and also a high level of details for the indoor or the engineering details. The like utilities, we have it is all outdoor, but we also have an access or a model that contains the engineering details and the relationship between the parts and each other. So now we can talk more about our solution or our technologies first. BIM is building information modeling or building information management. BIM helps us to have a graphical representation, and it is not just about graphical representation or 3D modeling. It contains also the information for each part in the building. Building information modeling provides graphical data and non-graphical data. So you have a graphical representation, 3D graphical representation, and each part or each element in the model have each element has its own properties or information, and of course it can be maximized, or we can add more properties. The main difference between BIM and GIS, both of them are sons for the traditional CAD systems, but GIS is open. You can create whatever table you need, and you have just to choose which type of geometry you need to use, whatever it's point, line, or polygon. But BIM is not like that. BIM models have its own predefined elements because it's for a certain industry, not like GIS. GIS is more generic. It is not related just to one industry, but BIM is for the AEC sector or the AEC industry, architecture, engineering, and construction. That's why we have a predefined elements like wall, maybe a control structure for some utility network, maybe a pipeline, something like that. So it also contains the relationship rules between the elements and each other. Not you don't have to create rules for the relationships between the elements, because it's predefined elements with the predefined properties. You can of course expand the properties and add more properties, but it has the enough intelligence to know what is the relationship between the elements. So building information modeling can be used for modeling the superstructure or buildings like residential buildings, or maybe a planet for utilities projects. Every element has its own properties. As we see, it can be used in both superstructure and infrastructure projects. It has its tabular data or its attributes. So BIM provide us with 3D visualization, 4D modeling, which is time simulation. You can link each element with the time progress, its time progress. So you have a time simulation or a 4D simulation for your project. Also, you can have the 5D model, which is linked, each element is linked with a certain with its cost data. So you have a full control for your model, 3D visualization, and also time and cost simulation per day. So you can watch the cost and time simulation in different phases of the project. And of course, clash detection. Clash detection is to define the potential problems that you might face in the construction phase. So if there is two elements that cannot be intersected or cannot be clashed or cannot be tangent, so the model have enough intelligence to warn you that there is a mistake here that can cause a problem in the execution phase or in the construction phase. Of course, without BIM, you may face problems like that. So maybe a duct and a beam in a building that's supposed to be clashed in the model, but it cannot be like that in the real way. So you have to stop the project and send an RFI or a request for information and wait for a couple of days to receive the final decision. It can happen if you have multiple utility networks underground, and for example, an electrical trench will be intersected with a water pipeline. So you have to stop the project and wait for the final decision. All of this won't happen if you have an aggregate BIM model that contains all of the disciplines in one central model to have a clash detection before you go to the next phase of the construction. What are the current industry challenges? First thing is the lack of communication between stakeholders, between different stakeholders. Every project have multiple teams that work on it, like the civil engineers, the mechanical engineers, the electrical engineers. Maybe we have also architecture, plumbing. It of course depends on the type of the project. So any type of projects we has multiple teams that work on it, and of course this can cause a lot of conflicts because we can't see the perspective of the other team. We can't put ourselves in their shoes. That can cause a big problem. and waste, of course, a lot of time, effort, and money. Another challenge is we have multiple data sources in each project. Of course, we have survey points, we have existing networks, the hydraulic analysis, the data from the design phase, the execution data, and the following up and the monitoring data for the project in the execution phase, the costs, and also the GIS and the inspection data in the facility management process or in the operation phase. So we have a multiple data sources that is not connected, and of course it can be conflicted. So you can have two copies of the same information, and it is different in different data sources. So we need a single source of truth or of information to avoid the conflicts and ambiguity. So we are proposing a one integrated platform solution, an end-to-end utility smart management system using both BIM and GIS. In the design workflow, of course, we need to create surface for survey points, because our utility networks needs to have the information of the surface that it's underneath. So if we have like a water utility or a sewer utility, whatever the type of utility we deal with, we need to have this information, because it will affect the shape of the alignment of or the profile of the pipeline. It will help us to define what type of control structure, maybe to increase the level of the fluid that move inside the pipeline, or maybe to decrease it. So we need this type of information. But if you have this survey points from the site and added to the our GIS platform as usual, now we can connect to it from the BIM environment to connect to the GIS system when I am in the BIM environment, and get this type of information without an offline connection. Offline connection, I mean, you can have it on a flash memory, or you have a paperwork or whatever. No, you now from inside the BIM environment, you can connect to the survey points from the GIS system, and just by one click you can create a surface that can be used and very beneficial to know what can the alignment or the profile of the pipeline will be. In the traditional way, it can take a long time to create such a simple step, like creating alignments or the pipeline profiles. Of course, we need to create part list, contain the sizes of the pipeline, the fittings, the materials. We need to create alignments, as we said, and also we need to create shop drawings, and shop drawings that is the type of drawings that we need to be ready for the execution. Also, we need schedules and BOQs, or bill of quantities, as we mentioned that every part or every element in the BIM model contains its data, including the cost and the quantity. That's why we can export schedules for cost, for quantities, and whatever we need. And of course, the clash detection, because the model is intelligent enough to define what is wrong and what cannot be happened, what cannot be happening in the model, like two networks clashes, two types of networks clashes. So it's like topology rules in JS, if you are familiar with, but it also works on the third dimension. So the BIM is not just for the infrastructure utilities. It also complete the full cycle. We may need in the utilities project to build a planet or some building for maybe residential for the field workers or something. So the buildings or superstructure is part of the utility networks projects or the infrastructure projects. So the BIM provides also in the design phase the modeling, including the schedules and bill of quantities, and also the coordination between different disciplines to have the early clash detection to avoid the problems that can happen in the site if we don't have such technology or such solution. So whatever the type of the project, whatever it's a subsurface network or it's a planet, superstructure planet, it all can be done using this solution. You don't have this big amount of drawings. Yeah, some types of projects or some projects we need a guy to just arrange the drawings. We have a large number of drawings. Now we don't need that. We have just one model, including all types of drawings, all bill of quantities, and of course properties, and added to that the visualization in a 3D way. So BIM is not about 3D. 3D is just the least value that BIM can add. The 3D visualization is just a simple value that BIM add, but it's also about have a single source of truth, a single source of information. You can extract whatever drawings you need, whatever schedules, and it has all the properties we need in based on the phase of the project. All of that we have passed by the planning, design, construction. Then now we are ready for the as-built or the project as it is implemented, because of course when we arrive the construction phase, something can happen to and some changes can apply for the design. So we need these updates to be automatically updated on the design to have an accurate as-built that is ready for the operation phase. So as we can see here is the JS environment with the layers on the left for superstructure example and infrastructure example. So we now we can import it in the BIM data in the JS environment without any effort. It's just a few clicks to have an as-built in the JS environment to be ready for the operation phase. So in the facility management is just it is not just about the data. The data is the foundation of the facility management, but also we need to use and utilize this type of data in system to be more efficient, to do the facility management in a more efficient way. So we have an incident maybe, so we need to analyze the incident, to take an action and export a report. That in this single source of truth solution in one integrated platform, this will reduce time to respond because of all of your data in just one place, to reduce the wasted resources. Here we have a case study we developed in-house for 9 types of utility networks, including water, sewer, and firefighting, and 5 types of electrical networks. These 9 types of utilities, all in one aggregate model to do the clash detection and the coordination between different disciplines. So we don't face any problem in the construction phase, and also to have an accurate as-built in the facility management phase. You can download the full case study from my LinkedIn account, Hisham Gamal Gafar. Also, we can use the dashboards to have insights from different data, whatever it's BIM or GIS, to have full control or a common operating picture for the project. And of course, if you are interested in these type of solutions, you can visit my LinkedIn profile, Hisham Gamal Gafar. As you can see here, I have multiple articles about the BIM-GIS integration and how can we utilize it in the EEC project. Glad to meet you today, in the day we all celebrate our appreciation for the GIS technology, and I hope we can meet again, and I hope it was useful for you. Thank you. See you again.